All right, here we go. Our objective for today, I can solve systems of linear equation by substitution. Let's read it together. 1, 2, 3. I can solve systems of linear equation by substitution. So yesterday we already started with systems of equation, and pretty much we're still on the same concept, right? Tell your neighbor the concept we're on. The only thing yesterday we solved by graphing. Today we're going to be doing it another way. That's why you didn't get a graph paper from the back. There weren't any. You guys notice that? Yeah. Today we're going to do a different method, and the method is called substitution. So I need you guys to focus on this one. It requires multiple steps. However, if you do each step at a time, you'll be able to follow along. So here we go. Systems of equations, systems of linear equations, we already went over the definition. We said it's a set of two or more linear equations that have the same variable. That's the most important thing to remember. Here they are, two or more, same variables, two or more, same variables, two or more, same variables. These were non-examples because there are two, but they don't have the same variables. And this one's only one. So they need to be two or more linear equations with the same variable. Steps. I gave you guys some steps. So in order to remember these steps, make sure we circle stuff. So first step, I want you to circle solve and underline where it says for one variable. So first step, solve one of the equations for one variable. 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 Step one. Step two. Substitute that equation into the second equation. Substitute that equation into the second equation. Substitute that equation into the second equation. Substitute that equation into the second equation with your color code, if you have it. Step three, solve that equation for the remaining variable. 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 Step four, substitute the value of the known variable to one of the two equations and solve for the last variable. Substitute the value of the known variable to one of the two equations and solve for the last variable. Substitute the value of the known variable to one of the equations and solve for the last variable. And our last step, write as a coordinate and check. What are we checking? How do we check? We substitute into both equations to see if they're true. Remember that, what we did yesterday? Yes. Especially those of you that did all your homework. Appreciate it. How you check that point into each equation to see if it's true. Okay, good. All right, so it's 5 basic steps. So I'm going to go ahead and do the first example. I need you guys to copy this. So right underneath the steps, copy this example down, example number 1. Example 1. I want you to write example 1, solve the system by substitution. And copy this system, please. Do that right now. All right, pens down, eyes up here. Please focus on this one. This one has a lot of substitution and a lot of going back and forth. If you're not focused, you're not going to get this example. And on the second one that I give you for you to practice, you might not get it. So I'm asking you to pay attention. Pens down, eyes up here. Here it goes. They're asking us to solve this system by substitution. So, therefore, in order for me to keep track of how many equations I have, I usually label these, and I know that this is equation number 1, this is equation number 2, just for me to keep track, okay? Because once we get into systems of 3 equations, which is algebra 2, which we are going to go through, I'm going to show you that, I need you guys to keep track of which equation you're working on. Are we there? Okay, so check this out. Step 1 says solve one of the equations for one variable. Everybody look up to the screen, please. We have 2 equations. We need to solve one of them for one equation. Does it matter which equation? I mean, no. Does it matter which variable? No. So basically, I look at it, are any of these solved for y or for x? No. So therefore, I'm going to take the second one and I'm going to solve for one variable. I'm going to solve on this one for x. So I'm going to get rid of this y. How do I get rid of y? We already know which doing the inverse. What is the inverse? Add y, add y. So we're left with x equals y plus 5. So step 1 is solve one of the equations for one variable. Copy that, please. All right, I'm going to label here my first step with Roman numeral, so like that I keep track of my steps. So step 1 is solving one of the equations for one variable. I'm done with that. Okay? Step 2. Step 2 says substitute that equation into the other, or it says into the second equation. Are we there? So I'm going to substitute this one into this first equation. So step 2, check this out. I'm going to label it here. Step 2. You're just paying attention. I'm going to substitute this one into the first one. So I'm going to rewrite this one right here. X plus 2y equals -1. However, you're saying, how do I substitute that, Mr. Q? Well, check this out. What did we solve here for? X. And what is X? Y plus 5. So for the second one, instead of writing X, I'm going to write what? Y plus 5. So check this out. I'm going to substitute that in here. Y plus 5. I bring everything else down. Plus 2y equals -1. That's step 2. Copy that, please. Pens down, eyes up here. All right, so step 1, just to double check, step 1, we solve one of the equations for one variable. There it is. Step 2, we substitute that equation into the other. There it is. We did that. Step 3. Step 3. You're just paying attention. For step 3, I'm going to solve this equation for the remaining variable. Do you see that there's only one type of variable in this equation? Which is y. Can we solve this equation? Yes. Can we combine like terms here? 1y plus 2y, that's 3y. I bring down the plus 5 equal to -1. Do we know what to do from there to solve? Yes. Copy that and finish that equation, please. Solve for y. All right. So to solve this one, we use inverse operation. Subtract 5 from each side. We're left with 3y equal to -6. At the end, we divide by 3. Divide by 3. Y is equal to -2. Hands if you got that by yourself. Okay. So step 3 is done. So we, once again, step 1, solve one of the equations for one variable. Step 2, substitute that one into one of the equations, or the second one. There it is. Step 3, we solve for the remaining variable. Okay. Pens down, eyes up here. Here goes the tricky part for some of us. Here it goes. Pens down, pay attention. Step 4. For step 4, we need to take this value and substitute it into one of the equations. Does it tell us which one? No. You choose whichever one. Okay? So, to me, I think the easiest will be to substitute in the second one because it doesn't have anything else being multiplied or divided. So I'm going to write the second equation. Check this out. I rewrite it. X minus y equals 5. But now I need to substitute the value for one of the variables. Do we have one of the values? Yes, y equals -2. So instead of y here, what do I write? -2. And I bring everything else down. The x, the minus, the equal, and the 5. And we know that here's multiplication. Is that correct? I'm going to show you that with the parentheses. So what is negative times a negative? Positive. And now we just solve for the remainder. So what do I do to solve for x? Subtract 2 from each side. Subtract 2 from each side. So x equals 3. Copy that, please. All right, so check this out. Once again, our steps. Step 1, solve one of the equations for one variable. Did we do that? Yes. Step 2, substitute that one into the other equation. Did we do that? Yes. Step 3, solve for the remaining of that variable. Did we do that? Step 4, substitute that variable into one of the two equations. Yes, we did that, and we solved for the remaining variable. So now, yesterday, according to what we found, when we graphed the two lines of a system, the solution was a point of intersection, wasn't it? What does a point of intersection need? An x value and a y value. So therefore, do we have an x and a y value? So step number 5, we write it as a coordinate. Step number 5. Step 5, we write it as a coordinate. The coordinate is 3, -2, and we write solution. Copy that, please. Boom. So, check this out. Step 5 says, look at your notes, it says, write as a coordinate and check. So therefore, we already know how to check, so check this out. So part of step 5, you need to rewrite these two. I need to write them here. X plus 2y equals -1, and I'm going to write the other one right here. X minus y equals 5. And to check, all I need to do is substitute the value of x and the value of y for each one to see if it's true. Remember that? So check this out. So what is my x value? 3. And what is my y value? -2. I bring everything else down. Plus 2. Here's multiplication equals to -1. What is 2 times -2? -4. I bring down the 3, the equal, the -1. What is 3 minus 4? -1. Is -1 equal to -1? Yes, that's true. So I'm going to do the same over here. I substitute the value of x is 3. The value of y is what? -2. And I bring everything else down. The minus, the equal, and the 5. Since there's two negatives here, it's a multiplication. Negative times a negative. Positive. What is 3 plus 2? 5. Is 5 equal to 5? Yes. So therefore, all we have left is to write a statement. Our statement is the solution to the system is, parentheses, 3, -2. The solution to the system is 3, -2. Okay? However, because, why is it the solution? It makes both equations what? True. It makes both equations true. Copy that, please. The solution to the system is 3, -2 because it makes both equations true. Okay. Okay. Thank you. All right, let's see. Let's see what we got. So, let's go over our steps to make sure we got it. Step 1. Solve one of the equations for one variable. Did we do that? Yes, right here. Step 2. We substitute this equation into the other. Yes, here it is. Step 3. Solve for the remaining variable for that equation. Yes, there it is. Step 4. Substitute this variable, the value of this variable, into one of the equations. Yes, we did that, and solve for the remaining variable. Step 5. Write as a coordinate and check. Did we do that? Yes, and we wrote our statement. Okay, that's pretty much it. Okay, I know it's pretty lengthy, but it's doable, step by step. So let's do one together. Copy this next one down, please. Example number 2. Copy that one, please. Example. Okay, example number 2. Example 2, solve the system by substitution. The system that they gave us is y equals x plus 1. And the second one is 4x plus y equals 6. If you write with big font, copy this one in the back and do it in the back because there's different steps that you need to do, right? All right, go for it. Okay, here we go. Let's do this together. Make sure we go over the steps. Step 1, solve one of the equations for one variable. Let's look at it. Is at least one of the equations already solved for one variable? Yes, the first one. It's already solved. So therefore, step 1 is done. Step 1, they already did it for us. There it is. Or I'm going to label this equation 1, and equation 2 so I can keep organized, okay? So step 1 is done. Step 2, what do we have to do for step 2? Substitute this equation into the other. So check this out. Y is x plus 1. So here, instead of y, what do I write? X plus 1. So I write x plus 1. And I bring everything else down. 4x, the plus, the equals, and the 6. Okay, so therefore, step 3, we can combine like terms and solve for the remaining variable. That's step 3. Can you solve that one by yourself? Yeah? So let's do it together. 4x plus 1x, that's what? 5x plus 1 equals 6. So let's solve that. We subtract 1, subtract 1. We're left with 5x equals 5. And what's my last step? Divide by 5. Divide by 5. 5 over 5 is 1. 1 times x is x. And 5 over 5 is 1. Okay? Hands if you got x equals 1. Okay? So step 3 is done. Step 4, all we need to do now is substitute this value into one of the two equations. Which is the easiest one to substitute it? The first one. So I'm going to rewrite the first one, which is y equals x plus 1. And instead of x, what am I writing? 1. Instead of x, I'm going to substitute the value of 1, because that's what we got, right? So therefore, y equals plus 1. So what is 1 plus 1? Y equals 2. All right, so now we did step 1, 2, 3, 4. Step 5, we write it as a coordinate. Step 5, write it as a coordinate. I'm going to write over here, step 5. What is my coordinate? 1, 2, and that is our solution. Solution. And just to double check, what do we need to do? Check. Substitute into each equation. So I'm going to rewrite the equations. The first one right here, y equals x plus 1, and the other one is 4x plus y equals 6. And I have now my value for x and my value for y. So x is 1, and y is 2, and I bring everything else down. So what is 1 plus 1? 2. Is 2 equal to 2? Yes, that's true. So I do the same over here. Instead of x, it's 1. Instead of y is 2. Bring everything else down. The 4 is multiplying the x, so I open a parentheses right here. Plus 2 equals 6. What is 4 times 1? 4 plus 2 equals 6. Is 4 plus 2 equals 6? Yes. So therefore, it is our solution. So what is our statement? The solution to the system is 1, 2, because it makes both equations true. Boom. Okay, that was example number 2. Example number 3. Copy this one down, please. Last one. Yes, copy it down. Okay, here we go. Example number 3. Example 3. Solve, and it gives the system y plus 6 equals 11, and 3x plus 2y equals negative 5. Okay, let's do this one together. So step 1, we need to solve one of the equations for one variable. Which one's the easiest to solve for a variable? This one, right? We can solve for y, so I'm going to rewrite it right here. Y plus 6 equals 11, and let's solve for y. So therefore, I subtract 6, oh, this is 6x, sorry, 6x. We're left with y equals negative 6x plus 11. Step 1 is done. We already solved one of the equations for a variable. Yes. Are we there? So that was step 1. Step 2, let's substitute this one into the other one. So I'm going to rewrite this one. Check this out. Step 2. Let me write this one. 3x plus 2y equals negative 5. But what is y? Negative 6x plus 11. So here, instead of y, I'm going to write negative 6x plus 11. But what's happening here to y? The 2 is doing what? Multiplying. So make sure you write that in the parentheses and you write the 2 multiplying that. And let's bring everything else down. 3x plus equals negative 5. So now let's solve that. For step 3, we need to solve for the variable. But before that, we need to distribute the 2, don't we? Yeah, so let's distribute that. 2 times negative 6, negative 12x. 2 times 11, positive 22. Bring everything else down. Okay. Combine like terms. 3x minus 12x, that's negative 9x. Bring down the plus 22 equals negative 5. From there, we subtract 22 from each side. We're left with negative 9x equals negative 27. And at the end, we divide by negative 9. Negative 9. X equals 3. So that was step 2, and then step 3 once we solve for the variable, right? So now step 4. For step 4, we need to substitute this value into one of the equations. Which is the easiest one to substitute into? Very good, the first one. We write y plus 6x equals 11. But instead of x, what do we write? 3. Bring everything else down. Y plus 6 times 3 equals 11. So let's see, what is 6 times 3? Y plus 18 equals 11. And what do we do at the end? Subtract 18 from each side. We're left with y equals negative 7. Hands if you got negative 7. Okay, good. And the last step, we need to write our solution as a coordinate. So check this out. So what is our solution for this one? 3, negative 7. And all we have to do is check and write our statement. Is that correct? All right. So our homework. Oh, and this is solution. Solution. Okay. So homework is found on page, what's the page? 340. Page 340 to 341. Numbers 1 through 25 odd. All right, turn in your homework on your way out. Enjoy your homework. See you guys tomorrow.